In this lesson, we are going to go over stem and leaf diagrams. And a stem and leaf diagram just shows the frequency of values in a data set. And you can also use a frequency distribution table and a histogram to display the same types of data. So what we're going to do is we're going to look at the following data set and show how you would present this data in each of those three forms, and so you can kind of compare and see how they relate to each other. And so if one of the methods doesn't really make much sense to you, you can look at another one to help understand it a little bit better. And so a frequency distribution table will look like this. We will have our frequency class, and then we're going to have our frequency. And so for this data set, we see our smallest number is 12 and our biggest is 41. So if we do frequency classes of tens, we can say 10 to 19 will be our first class, and then we can have 20 to 29 be our second class, and then 30 to 39, and finally 40 to 49. And you can make your frequency classes however you want. We could have done it by 5s, or we could have done by 15s, whatever you want. And so now if we look at this, we want to find how many numbers fall within this frequency class of 10 to 19. And we see that we have the numbers 12 and 13, so it has a frequency of 2. And then if we look at 20 to 29, we see we have 21 and 27, so again our frequency is 2. And then 30 to 39, we have the values 33, 34, 35, and 37. So now we have 4 in that frequency class. And then in our last class, we have 2 40s and a 41 to give us a frequency of 3. And so this is how you would do a frequency distribution table. And next, if we look at a histogram, we're going to draw it like this. And we have our frequency on the left, and then we make what I'll call our bins across the bottom. So it's kind of like our frequency classes from our last diagram. And so again, if we look at the space between the 10 and the 20, we have 2, so we're going to go up to 2 on our frequency side. So you can kind of tell that this is the 10 to 20 relates to our frequency class of our last diagram, and we go up to 2. And same thing with 20 to 30, we have 2 as our frequency, and then we go up to 4 for the 30 to 40 group, and then the 40 to 50 group, we're at 3. So that is what a histogram would look like. Just recording the frequencies of basically our different little frequency classes or bins. And next, if we do a stem and leaf plot, the benefit of doing a stem and leaf plot is it allows us to see the same information, but then we also get each of our individual data points is still listed. Individual data points. Because if you look at the other ones, we can't tell that we have a 12 and a 13. We just know we have 2 numbers between 10 and 19. When we do the stem and leaf plot, we'll see that we are still able to see each individual data point. So our stem corresponds to our tens digit. And so the plot will look like this. We have a stem here, and then we have our leaf here. And then our leaves are our ones digits from each of our data points. And so our stem will be 1, 2, 3, 4. Because if we look at the tens digit on all of our numbers, that's what they are. And then, so if we look at our leaves, this is our ones digit. We know we have a 12 and a 13, so we'll put a 2 and then a space, leave a little bit of room, and we'll have a 3. So we can see we have a 12 and a 13. And then if we look at the 2 stem, we know we have a 21 and a 27, so we'll put a 1 here and then a 7 to represent those two numbers. And then for our 30 to 39 values, we have 33, so we put a 3, 34, so we put a 4, then 35, and 37. And then finally, for the 40s, we have two 40s. So this means that we put the 0 down twice because that ones digit needs to be represented twice. And then we have a 41, so we just place a 1. And so this is what our stem and leaf plot would look like. And it is important to note that the horizontal leaves correspond to the vertical bars of the histogram. And so that's kind of how those two relate to each other. You can kind of see it's basically just kind of flipping it on its side almost. And then also we can note that the length of the leaves is equal to the numbers in our frequency table. So that is kind of how each of them relate to each other. And you can see that they all show the same data, except the stem and leaf plot has the added benefit of displaying each individual data point.